Hi students, going to the very important theory or beginning of this chapter's theorems. We are learning that Biot Savart's law. I have drawn one current carrying conductor in front of you. That's its whole length would be called as a dl, or let's say I'm just putting that the whole length is L, and from that current is passing, and is likewise our Coulomb's law, current is also coming outside. The net amount of current going inside is coming outside. I have placed one red portion which is called as a smaller length segment. From that also current is passing, which is been shown as that dl length segment. Because of that current is passing, current is either coming inside or going outside. Yes, it is called as a, as per our thumb rule. Now we are just learning thumb rule. Thumb rule is suggesting us, let's say assuming that this is our my pen, which is called as a current carrying conductor. So just holding like my thumb is indicating the direction of the current. So my fingers directions are shown as the direction of magnetic field. So magnetic field lines are going like that. It is called as a three-dimensional geometry. So sometimes in this chapter we will use cross and dot notation. So you can use any direction, either current is here which is coming outside, you can use vice versa and your current will be coming outside. So your direction of a cross or dot, our cross is indicating that magnetic field lines are just going inside. So I will place cross over here, and outside means magnetic field lines are coming out from here, so that is called as our dot notation. So these are the usual conventional things. Yes, you can use any notation which is convenient to you, but general terms in general reference books you will find out such type of cross and dot notations. Let's, as per my theorem, I have one point P where my magnetic field lines are going inside. Because of the current, magnetic field is produced which is making an angle of theta. So for very first thing I can conclude is that my magnetic field over at this point is dB. So dB is directly proportional to amount of current, means my magnetic field is proportional to current. Next one, it is called as a magnetic field is directly proportional to the length segment. As my length segment increases, my magnetic field is also increasing. Third part is my magnetic field is also directly proportional to the angle with which it is associated. And the fourth one is called as that distance. Let's say here to here my distance is like that. It is called as the inversely proportionality. So as my distance increases, it is called as the inverse square law. Likewise our forces or Coulomb's law. So my magnetic field is directly proportional to the current or electric charge, that length, that angle, and inversely proportional to distance between them. And that assuming that all those things are directly proportionality, so I have one constant k which is called as I dl sine theta divided by r square, where my k is called as a proportionality constant, which we will place that mu 0 divided by 4 pi. If you remember chapter number 1, we have epsilon 0. It is called as here permeability of vacuum. It is so similar that it is also having value 4 pi cross 10 to the power minus 7. So this is the new thing for you, because right now up to this chapter 1 and 2 we are dealing with the epsilon 0. Right now we have a mu 0. It is called as a permeability of a vacuum. If I have a media, so in future, instead of my entire arrangement placed right now in a vacuum, if it has been placed in the media, so my equation will be also like that, mu 0 by 4 pi. It is called as a permeability of a material. Yes, we will go into another part. What is the relation between that? So I am putting that value of k, which is called as a mu 0 divided by 4 pi. So I am putting this value, so I can get that dB is equals to mu 0 divided by 4 pi IDL sine theta divided by r square. Friends, first of all we want to just place that this is the dl, this one is the sine theta, and r square would be there. General term we will just place that dB is equals to mu 0 upon 4 pi idl sine theta r square and r cap. What is r cap? So you can just see this figure. This is the direction in which our magnetic field has been there, that this part is called as r cap. This is the direction of it. So right now we are putting that r cap. So in 11th science you have learned that r cap is called as a vector itself divided by its magnitude. So I am putting all those things together. dB is okay. Mu 0 and 4 pi is called as a constant. It is called as a scalar quantity. I is okay. Right now I am putting that a vector part. This is also vector part. Then this would be sine theta. I have a vector r, and this would be r square and modulus of vector r. So you are aware that it is called as a generally r. So my equation I can place like that: mu 0 upon 4 pi ideal cross vector r divided by r cube, because I have placed that dl cross vector r is called as r dl sine theta. So my sine theta is absorbed in the cross product. So my equation is right now ready. So you can first of all correlate that, and generally we will use this one: dB mu 0 by 4 pi r square. So you are aware electric field is inversely proportional to square distance is square, same is the cos. Our magnetic field is directly proportional to I, d, l and sine theta, but inversely squarely proportional to the distance between them. So this is the relationship of a magnetic field, and it is holding some of the basic constants. Going to the unit, that is called as a mu 0. We have just placed previously its value. Now it is the turn of its units. The very first unit of a mu 0 upon 4 pi is called as a Weber per ampere meter. But you are aware that I have placed previously 1 Tesla is equals to Weber per meter square. So I can have another unit. So Weber is equals to meter square and Tesla divided by ampere meter. So my unit of a mu 0, it is called as a Tesla meter per ampere, which is widely used units. As you are aware about its dimensional configuration of Tesla, which is called as M1, T minus 2 and A minus 1. This is meter, this one is called as ampere. So I can have directly dimensional configuration of mu 0 is equals to M1 L1 T minus 2 and A minus 2. So this is dimensional configuration of mu 0. Now you are asking that what is also the unit of a mu, because we have also said that what about mu. The unit of a mu is called as a permeability of a material, which also holds the same unit like this one. Next thing we are aware about, that is called as a relationship. It is called as a ratio of two quantities. It is called as a relative permeability of magnetic quantities. So mu is called as a permeability of material, and this is called as a permeability of vacuum. Always we are comparing these two quantities, and our answer would be either higher, greater than 1, or equals to 1, or less than 1. It means that our media in which we have placed our current carrying conductor and what amount of magnetic force we will receive. So this is the ideal condition. Mind well, this mu r is a unitless quantity, so it does not contain dimensional configuration. So either they are asking that epsilon or epsilon 0, or mu r mu by mu 0. This quantity is called as a relative permittivity, and this one is called as a relative permeability. Both are unitless quantity. So afterwards we will move to the another theorem. Thank you.